Good afternoon or morning, class. This is Introduction to Statistics, Math 21, Spring 2020, College of the Sequoias. And in this section, we're going to be looking at Chapter 11. Chapter 11 looks at doing hypothesis testing with two samples. So Chapter 11 is hypothesis testing from two samples. Two sample groups. Now, before we dig in, I want to just do a quick refresher, see what you remember. What is a confidence interval? Stop and think, pause the video for a second, see if you can put into words what a confidence interval is. Well, a confidence interval, it's a range of values that is based on sample data that is likely to include an unknown population parameter. Remember, parameter is when it applies to a population. Statistic is for a sample. So the options we've looked at proportion, we've looked at mean, we could do standard deviation, and they often use variance as well. And how is that different than a hypothesis test? Well, what is a hypothesis test? This is a process for testing a claim, again, based on sample data, made about an unknown population parameter. And so we can see these are very related. Based on sample data, unknown population parameter, unknown population parameter. One of them is just what the range of values is, and the other is a little bit more than that. So something else I want to, this is from the lecture notes, I want you to see it. This is 11. Let's start looking at 11.1. Well, let's expand upon the hypothesis test a little bit more. The hypothesis test, it includes a previous value to check against. And what did we call that previous value? This was the null hypothesis, H0. And what's really going on is, does H0, the value of it, show up in our confidence interval? That's what the p-value just helps us decide. If it shows up in it, the p-value tells us without us having the confidence interval. Shows up in our confidence interval. Okay. So it is important that we recognize all of our old rules still apply. So this is 11.1 still. So we're looking at a two sample test for proportions. And all the old requirements still apply. Old requirements for one sample apply. So we want our samples to be independent. And random. Which means the selection for one sample group does not affect the selection for another. Affect the other. Like something that would break this, asking married couples and asking couples and putting guys in one group and girls in another, and placing guys in one group. Girls in another, or however you, if it's not a heterogeneous relationship, however you're breaking it down. This is not independent, because oftentimes when people are a couple, they have something that they get along on a lot of things. So if you ask one person, their partner might feel the same way. So that's one requirement. We're going to have two populations. Let's call them P1 and P2. And as you can see right here, we still want, and corresponding to that, N1 and N2. We need N1 P1 times 1 minus P1 to be greater than or equal to 10. We need N2 P2 times 1 minus P2 to be greater than or equal to 10. And we want also N1 to be less than or equal to 0.05 of the overall population for that group. And same thing with N2. Okay. So where do we find this in StatCrunch? In StatCrunch, we will use stats, proportion stats, two samples, and if we have data, we'll use with data. This is with each individual entry. There's a good chance we'll do with summary. This is normal. And power sample size, we looked at this in one sample. This can tell us the size N needs to be. And we'll look at that, okay? Now, how does this differ? Remember our hypothesis test? Most of the steps were the same. The step in hypothesis testing that changed for the most part only differ in step 1. What was step 1? State the null and alternate hypothesis. Now, the way people in stats normally do it is we say the null hypothesis is P1 equals P2. And then we can have either P1 doesn't equal, is less than, or is greater than P2. You'll see this works a little differently in StatCrunch. Let's bring that up right now. Stats, calculators. What's going on? Oh, there we go. I'm sorry. Stats, proportion stats. To sample with summary. Here, notice it says P1 minus P2. So StatCrunch, what they do is they subtract P2 from both sides. In fact, it's a good way to set it up. Write it as P1 equals P2 and go from there. So StatCrunch H0 is P1 minus P2 equals 0. And H1 is P1 minus P2. And then insert your symbol here, 0. The reason why they do this allows you to change the 0. To not just argue two proportions, or to not just argue the difference of two proportions, but how different. If we think P1 is going to have a lot higher proportion than P2, we might say we think they're 10% apart or 0.1 apart. So that allows us to change some things up. Okay. What you should do when you're working on a problem. So pro tips. After reading a problem or whatever you're working on, analyzing or interpreting the problem. Try this again. Pro tips. After analyzing or reading the problem, interpreting the problem, make a note of, well, let's say step 1, label population 1 in P2. If it's guys and girls, say which one's guys, which one's girls. Okay. If it's summarized data, remember P hat is X over N. So you might want to jot down for P1, list X1 and N1. And same thing for P2. Collect your info. The only other thing you ever had to do that might be different was identify alpha. So identify alpha. If it's unstated, use 0.05. Okay. All right. Let's take a look at some examples. This is why we don't do it by hand. Look at that horrible formula. No, 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 no. Don't do that. Bad juju right there. The rule still stays the same. If the p-val is too low, reject the reject the null hypothesis. Okay. So the first example we're going to look at is, let's see, in the lecture notes, I'm going to be on page 123. We'll have it right there. So lecture notes, page 123. This says example 2 in 11.1. An economist believes the percentage of urban households with internet access is greater than, I have the hardest time saying rural. I'm going to say country. So greater than rural, or greater than the percentage. The problem says rural. I'm going to say country, because that's kind of the same thing. Of country homes, okay? So urban homes have a greater percentage of internet access than country homes. So he samples 800 urban households. And finds 338 have access. Of 750 country homes, 292 have access. Test the claim at alpha equals 0.05 level of significance. So I'm reading through it and it gives me two groups. It tells me there's an urban group and a country group. It's a good idea to label them. Let's label them. It doesn't matter how you label them, but it changes the alternate hypothesis. So let's look at both setups. So if we say population 1 is urban, population 2 is country, in both cases, H naught equals or is P1 minus P2 equals 0. The alternate hypothesis, HA, well, we had P1 equals P2, but we wanted to say P1 is that the urban households are greater than country. So we're going to say P1 is greater than P2. We subtract P2 from both sides, and we get P1 minus P2 is greater than 0. If, on the other hand, you said P1 is country, and P2 is urban, again, the H naught stays the same. But here, we want the urban ones to be greater, so the alligator is going to go towards P2, the urban. And when I subtract P2 from both sides, I get P1 minus P2 is less than 0. Now, personally, I don't like the second option. Why? The wording up here says greater than, this symbol says less than. It's the correct one for the way we labeled the groups, but when I see it, it confuses me. It makes me go, did I do the right thing? So you might want to try to set up your problem so that the symbol matches what it says. To do that, you have to pick your population 1 and population 2 accordingly, okay? So let's use the green one. Let's use the top one. So we're going to go with P1 is urban. And he told me that N1 was 800 people. X1 was 338 have access. P2 is country. N2 was 750. X2 was 292. Note the samples don't have to be the same size. Okay. We can test our claims. What proportion, what is P1 hat here? Let's see what P1 hat is. P1 hat is 338 over 800. P2 hat is 292 over 750. I'll go to 4 decimal places here as well. Do we satisfy the conditions? You should do this every time. Are they independent? Notice he says he obtains a random sample. It says random sample, and there's no linking in there. And there's no reason to think country homes and urban homes have any relationship because they're in different regions. So yes, independent. Then we got to check N1 P1 times 1 minus P1. Is that greater than or equal to 10? I've got 800 times 0.4225 times 1 minus 0.4225. What do I get for that? Times 0.4225 times parentheses 1 minus 0.4225. And that is 195.195 is greater than or equal to 10. Now, if we're looking at American households, N1 is definitely less than 5% of all the urban households in the country. Now we check N2 P2. Is that greater than or equal to 10? It already looks pretty clear. There's a lot more than 750 country homes in the country. So N2 is definitely less than 5% of the country's population country homes. What do we have for this one? Here, N2 is 750. P2 is 0.3893. And then we do 1 minus that. What do we get? This is 178.309, which is also definitely greater than or equal to 10. So our conditions have been satisfied. Now, I'm betting you probably won't do this when you're going through and doing the homework, but in reality, you want this to make sure that if you're ever doing this for your job, you want this to apply. Okay, so let's do our hypothesis test. Our hypothesis test. I'm going to make sure I label them. P1 is urban, P2 is country. I liked that setup better because the symbol worked well. Step 1 is always identify H0 and HA, or H1. They say the same thing. Different people use different things. Here we're going to go with P1 minus P2 equals 0, and P1 minus P2 is greater than 0. This says there's no difference in setting, whether you're urban or country, and this says urban has greater access. To internet than country. Then we want to make sure we identify our level of significance, alpha, that was given to us, 0.05. And now step 3, we go to StatCrunch. So let me do a new data table. We're going to go stats, proportion stats, to sample with summary. I do not have each address listed and whether or not it's rural, country or urban, and whether or not it has access or not. So we're going to say summary. I labeled sample 1 my urban one. So my urban data, I jotted down that the number of successes, X1, was 338. There were 800 people. And our country group, 292 had access out of 750. I'm going to leave P1 minus P2 equals 0, and I'm going to change this to be greater than. I click compute, and it gives me the following information. It tells me my Z-stat is 1.33. My p-value is 0.092. Okay. Step 4, make a decision. Is the p-value less than alpha? So that's my p-value. Alpha was 0.05. Which one's bigger? P-value is. So if the p-val is too low, the null must go. The p-val is not too low. So we don't reject the null hypothesis. So DNR H0 do not reject the null hypothesis, which means we do not support HA. Okay, so now we make a statement about what it was saying. HA was that urban households have greater access to internet than country homes. We're not supporting it. There is insufficient evidence to support the economist's claim that urban homes have greater access to internet than country homes. Okay. So recap, we went stats, proportion stats, to sample with summary. We enter in we label sample 1, sample 2, the different populations, and we plug in the information according to each of them. We make sure we use the right symbol in the drop-down menu for the alternate hypothesis. We click compute and everything goes as normal. And how did this relate to confidence intervals? Let's look at our confidence interval. This was one-tailed, so we have to double alpha for the CI. 90%. So I'm just going to edit this. I'm going to change this confidence interval to 90%. My lower limit, negative 0.0078. Upper limit is 0.0742. And remember, we're checking to see whether or not H0, does H0's value lie within the CI, within the confidence interval. Notice when you do the confidence interval, it's telling you what's being stated. They're showing you the values for P1 minus P2. P1 minus P2. H0, P1 minus P2 was 0. So, does 0 lie in the interval? Yes, it does. The lower limit is negative 0.0078. That's less than 0. The upper limit is 0.0742. That's greater than 0. 0 is between them. So since H0 is in the region, we can't reject it. Would this have mattered if I said 95% if I didn't double alpha? Nope. If I hadn't doubled alpha, it still would have worked. Okay. So let's take a look at another one. This one's a fun one. This was a project done by former COS students as part of their semester project. A group of COS students feel there is a difference between the proportion of female students that change their major at least once and male students. The two groups have different proportions. So they surveyed 80 female students and 86 males. 39 females said yes. 39 females and 51 males had changed their majors. Test the claim, test their claim at alpha equals 0.05. I would like you to do this. I want you to do this. Make sure you check the conditions. And if they work, do the test. Hell, even if they don't, do the test. For the practice. Now, if it doesn't work, if the conditions aren't met, it just lets you know that the results may not be as reliable as you want. You should go out and collect more people. Pause the video and work that out. All right, let's take a look at it together. I'm going to label the first group they said was females, so I'm going to say that's P1, which means P2 is males. And so P1 had X1 was 39 females. I'm pulling it right off that page right above. 39 females out of 80 students. And X2 had 51 males out of 86 males. So P1 is X1 over N1, 39 over 80. P2 is X2 over N2, 51 over 86. And we'll do 4 decimal places again, just because I had 4 in the last one. Okay, so for both of them, N1 is definitely less than 5% of all the female students at the school. And N2 is definitely less than 5% of all the male students. That's confirmed. Let's check our N1 P1 times 1 minus P1. We've got 80 times 0.4875 times 1 minus 0.4875. 19.9875 is greater than or equal to 10. Good. N2P2, we got 86 times 0.5930 times 1 minus 0.5930. And this is 20.76 or 7562. That's also greater than or equal to 10. Are they independent? Well, let's read the problem. It says they surveyed 80 female students and 86 male students. It's really unclear if this was met or not. Did they ask couples? Let's assume so. Let's assume they did, but it was left unstated. The question is, what's going on here? How are we going to do our test? We have P1 equals P2, which leads to P1 minus P2 equals 0. What symbol should I be using in between? Does it matter which group I label P1 and P2? It says that there is a difference. They don't indicate what the difference is. Difference implies P1 does not equal P2. So it really doesn't matter which one we label. Because P1 minus P2, doesn't matter which group I call it, we're both going to end up with that symbol. So let's take a look at this. Let's do the test. Keep that data up where I can grab it. So what's our test? I'm going to keep P1 as females, which gave me 39 out of 80. P2 was males, which was 51 out of 86. H naught, P1 minus P2 equals 0. HA, P1 minus P2 does not equal 0. This says there is no difference between the genders. And this one says there is a difference. Sometimes writing down what H naught and HA in words can be really helpful, especially when you're getting down to the end and going, what's my conclusion here? They gave us alpha. So this was step 1. Step 2, identify alpha, the level of significance. They tell me alpha equals 0.05. So now we go to StatCrunch, do the rest. We're going to go to stats, proportion stats, to sample with summary. I've got the females were first, 39 out of 80. And here we had 51 out of 86. And I want to keep P1 minus P2 as not equal to. Click compute. My z-stat is negative 1.36. My p-value is 0.1727. Alpha is 0.05. Which one is larger? The p-value is. The p-values not too low. Do not reject the HO, or the null hypothesis, which means do not support the alternate hypothesis. The alternate hypothesis was there was a difference. So our conclusion is, I'll change the wording a little bit, there is not enough evidence to support the student's claim that females and males have different proportions of people that change their major. And I'm literally pulling that directly from the word problem. Test the student's claim that there's a difference between the proportion of female and male students that do it. I do want to point out to you, this is when I had it in this order. Let's change the order let's do the test again. And I'll show you when you have the inequality like this, let's make P1 the males and P2 the females. The only difference is the z-stat changes sign. Notice that? The z-stat changes sign. The p-value is the same. Okay? Both of them, if we go to a confidence interval, should get the same confidence interval. No, kind of different. Oh, the numbers just switch order. In both cases, 0 is between the lower limit and upper limit. So that's the idea there. Let's take a look at a couple homework problems. Let me get comfy in my chair. So I want to, this is from 11.1, homework examples. The 11.1 I'm looking at, let's see what we got here. Let's start with problem number 4. We'll look at number 4, number 7, number 10. Really? You don't want to load? Make it bigger so I can see it better. There we go. Once I get into the assignment, it's a little bit easier. We're going to look at 11.1. Let's start with number 4. So number 4, how many tattoos do you, so this is a tattoo problem. I'm not going to copy down the problem. We already did that. This is the tattoo problem. Let's just discuss what they've got. It looks like a survey asked how many tattoos do you currently have on your body. Of the 1,226 males, it looks like one of the populations is males. For that population, N is 1,226. 179 said they had at least one. So I'm taking notes. Then they asked females, so that'll be my other population. I haven't labeled them 1 or 2 yet because I don't know which way I want it to go yet. They say 1,013 females were asked and 141 had at least one. Construct a 95% confidence interval. So that's what they want. Whether the proportion of males that have at least one tattoo differs significantly from the others. So they went with differ, which means, and they even tell me what to use. Let P1 represent the males, that's nice. And P2 represent the females. They just want the confidence interval. So we're going to go to question help, StatCrunch. Stats, proportion stats, to sample with summary. They said do males first. So I had 179 students out of 1,226 for males. I had 141 out of 1,013 for females. Confidence interval, bam. So how many decimal places do they want? 3 decimal places. Let's bring that back up. So 3 decimal places. My lower limit is negative 0.022. My upper limit was 0.03, like I got around to 6. And just remember stats, proportion stats, to sample with summary. Let's enter that information. Negative 0.022, 0.036. Excellent. Okay, then I wanted to look at number 7. Why is it saying I'm not done? Oh, continue. There's more. Okay, so what is this saying? We got to interpret what it means. There's 95% confidence that the difference of the proportion is in the interval. Is that what that means? So if there's a difference, what we're aiming for here, P1 minus P2 equals 0 or it doesn't equal 0. So is 0 in the zone? Is it? The lower limit's negative, the upper limit's positive. Yes. So H0 is inside. We don't reject it. Which means there's not a significant difference between the two values. Which one says that? We are 95% confident that the difference of the proportions is in the interval. 2 of them say that for me, A and C. A says there is a significant difference, but if there was, it wouldn't be in the interval. C says there's insufficient evidence to say that there's a significant difference. That's what we have. There's not enough evidence to say that that's correct. Okay. Let's take a look at number 7. Number 7 is on determining sample sizes. For this problem, we want to use stats, proportion stats, to sample, power sample size. They tell me, if we read through the problem, let's read it. A physical therapist wants to determine the difference in the proportion of men and women who participate in regular sustained physical activity. What sample size should be obtained if she wants the estimate to be within 4 percentage points? Okay, so the estimate or error needs to be 4%, which would be 0.04. Remember, that's the arrow going error in each direction. So the overall width is 0.04 plus 0.04 equals 0.08. So in part A, she's got 0.227 male, 0.188 female, and in B, no prior values. When we have no prior values, set both to 0.05 or 0.5, sorry, the 50% mark. Okay, so we're gonna go StatCrunch. Stats, proportion stats, to sample, power sample size. Click on confidence interval. Confidence interval width, it says. They gave us a confidence level. They said 95%, that's important. We're gonna need that. So I'll make a note of that. CI is 95%. So what we do is, in this box, we enter in the confidence level that we want. We enter in our two proportions. Our two proportions were 0.227 and 0.188. I want the width to be double the error, and we want that in decimal form, so 0.08. That's 2 times 0.04. Sample size per group should be 788. So first proportion was 0.227. Second proportion, 0.188. CI was 95%. Width was 0.08, and we click compute. And it gave me n equals 788. Okay. Now, if they want it with no prior estimates, what you do, you can change these. First proportion changes to 0.5. Second proportion changes to 0.5. Make sure you reset the width to 0.08. sometimes it's far enough away that the answer is different. So you want to reset it and click compute. $12.01. Okay. And we'll take a look at number 10. This one only lets you do it once, so make sure you get it right. Number 10. In clinical trials of a medication, 2,097 subjects were divided into two groups. The 1,528 subjects in group 1 received the medication. The 569 in group 2 received a placebo. Of the 1,528 subjects in group 1, 52 experienced dizziness as a side effect. In group 2, 14 experienced dizziness as a side effect. To test whether the proportion experiencing dizziness in group 1 is greater than group 2, researchers enter the data into the statistical software and obtain the following results at alpha equals 0.1. It gives me my CI. Negative 0.006215 and 0.025069. And then it says the test for P1 minus P2 equals 0 versus greater than 0. What that means is HA is P1 minus P2 is greater than 0. They got the p-value to be 0.136, and the z-stat was 1.110. What conclusion can be drawn? So we have to compare the p-value versus alpha, right? They did all the work for us. Is p-value less than alpha? Is that less than 0.1? No. P-val is not too low. Do not reject the null hypothesis. Do not support the alternate one. So we have do not reject the null hypothesis. Two of them say that. There is not enough evidence to conclude that the proportion experiencing dizziness is in group 1 is greater. That's the one we want. Which one says it? For me, A says it. If there was enough evidence, we would reject H0, but there's not enough evidence. So we check our answer. Ta-da. All right, well, that's going to wrap up 11.1. And I'll be making a video for 11.2 shortly. Peace.